Hello, welcome to Livy's Ranger Garage. On this YouTube channel, I hope to produce a series of videos teaching you about automotive electrical systems. We will cover basic electricity, how to troubleshoot electrical problems, and how to add and modify circuits in your vehicle. These videos are primarily aimed at owners of Ford Rangers, Explorers, and Bronco 2s, but most of the principles here will also apply to other vehicles. My name is Eric, and this channel is named for my dog Livy. I hope you find these videos useful. Thanks for watching. Hello. Today we're going to talk about using our test equipment, using a test probe like this one, or maybe a meter, like a digital multimeter like this, or analog multimeter. I talked about the different meters in a previous lesson. You don't have to have something that costs several $100s like this one. I'll do most of this today with the cheap stuff so you can see that it works. So let's get started. And we'll use a test probe here. And you see I brought my sample circuit out here that I built a while back, and I have it hooked up to the truck's battery. So we have 12 volts coming in right here, a positive and negative. And we go to a fuse, then we have a switch, and then we're connected to this trailer clearance light over here. And then the ground circuit just comes back to the negative to the battery. So we'll start with this. Now let's talk about measuring voltage. You can test voltage with a simple test probe or test lead like this. And these are inexpensive, they're easy to get. There's a little bulb, I think it's usually a neon bulb in there or something like that. But anyways, that lights up when it sees 12 volts or when it sees a certain voltage range. It doesn't measure voltage, it doesn't tell you how much voltage is there, it just tells you there's enough to light up that light bulb. So to check for voltage in the circuit, you clamp your black lead of your test lead on the negative or on the ground, a good clean ground on the vehicle, and then touch the positive to the 12 volts. And there you see we have voltage there. We've got 12 volts coming in, or we have voltage coming in, and we can test it on the other side of the fuse. We have 12 volts, or we have voltage coming out of the fuse. And if you didn't know it, fuses quite often on these blade style fuses have little openings at the top here where you can stick a tiny probe down in there and touch each side of the fuse. So if it's a blown fuse, we would have voltage here, but not here. And that's the same as when I check for voltage here and here. If the fuse was blown, I would not see it here. The light would not light up. Just like across the switch. Here's our voltage coming to the switch, and here's our voltage coming away from the switch. So we have voltage here. The switch is off, so we do not have voltage here. And we do not have voltage at the light. Now when you're measuring voltage, you're measuring in parallel across a component or a group of components. I could just as easily check this across a switch by connecting my probe there on one side of the switch and connecting the other side on the incoming. And you see the light lights up because the test light is completing the circuit across the switch. I don't know if you can see it or not, but we're actually passing enough current for the light bulb to light up slightly. So when I do this, I'm completing the circuit. But now watch what happens when I turn the switch on. Aha! Now our test light went out. And that's because the test light is measuring a difference in voltage. Okay? With the switch off, we have a difference in voltage between the incoming and the outgoing side of the switch. So with the test probe hooked up like this, we can measure that. And we see that it's there. But when I close the switch, That's like just having a plain old piece of wire in between here with zero resistance. And that means that this point and this point are at the same voltage. Don't get mixed up and think you don't have voltage there, because as we saw before, if I'm hooked up here, okay, if I'm hooked up to a ground and I go here, there my light lights up, and it lights up on this side. So we do have voltage there. We can do the same thing at the light bulb. Okay, we can be hooked up. There's the ground side, and there's the voltage side. Now, we're measuring a difference in voltage. The light is dropping or using all 12 volts of our power that's available. So we have 12 volts here, and we have 0 here. And the 12 volts is doing work in the light. So we have a voltage difference across the light. And that's how you use a test probe. You can hook one side to ground and touch the other to anywhere on the circuit. You see, since that's on the ground, if I touch the other side of the probe to another ground point, you see that we still have no difference in voltage. So the light does not light up. And that's how you use a test probe. That's a very, very handy tool. It's a very simple, inexpensive tool, and it takes up almost no room in your toolbox. So that's an easy thing to carry. Now let's do some of this with the meters. We'll start with our cheap little analog multimeter here. And I'll just sit that right there. And to test voltage with your meter, you have to select the voltage range that you expect to see. Okay, now we know this is a 12 volt DC system, so we're going to select one of the voltage ranges in the DC volts section. If we use the 10 volt range, that's smaller than the voltage we're looking for, so every time we see 12 volts, the needle is just going to go to the maximum side of the scale. It's not really going to tell us anything. So we're going to select the 50 volt scale, because 12 volts fits nicely between 0 and 50 volts. And you look up here on your meter, okay, that's going to be one of the black scales, and you see we have one from 0, 10, 20, 30, 40, 50 volts. So the needle will track across there, and we'll hope to see it landing right around in this area at about 12 volts when we measure. Let's try that. So I put one side of the meter on the ground, or on the negative, and the other on 12 volts. And there we go. We have a reading. It's a little different than I expected, but this is a cheap meter too. So that's reading a little bit high. But you get the idea on what it's supposed to do. And we can do the same thing. I can leave that on the ground. I can check it coming out of the fuse, and there's my voltage there. I have it going into the switch, and I do not have it going out of the switch because I didn't turn the switch on. If I turn the switch on, see the lights on over there, and now there's our voltage coming out of the switch because we completed the circuit by closing the switch. We can come over here and check it going into the light, and there's our 12 volts. And like I did before with the test light, if I go to the ground side, if both meter leads are on the ground side, I measure 0 because there's no voltage difference there. I can do the same thing with the positive side. I can hook this lead over here to positive and hook this one to the positive going into the light, and you see the meter doesn't deflect. It doesn't read anything because those are at the same voltage level. So we're not reading any difference in voltage across there. But we read a voltage across the light bulb because the voltage is being used at the light. It's doing work. Yeah, let's see that again here with a digital one. We'll turn it on and we're going to select the 20 volt DC scale. Okay, it's reading 0, and there we go. I've got 12.5 volts, and so I can test anywhere in my circuit, and you see I got 12.3 there, but I had 12.5 at the incoming, so that means somewhere I have a bad connection. Let's check across the switch. Well, we're dropping 1/10 of a volt right there, so that's most of it. And we're dropping a little bit in the fuse holder. You see how I measure across something and I get a reading, and that shows me how much voltage is being dropped across that device. And in this case, across the fuse, that just means something's a little bit dirty or loose in there. So you could pull the fuse out and clean it up, and I could clean all these connections, and I could change that and probably clean it up and get it closer to 0. And we'll look across the light bulb. And there's our 12.34, okay, roughly 12.5. But you see how I did that? And that's how you can check your voltage. Now sometimes it's not convenient to hold the meter lead on the ground while you're over probing something else. So you can get some little wires with alligator clips like this. They're called test leads. And you can very carefully clip one of those to your meter lead and clip the other end on your ground. And now I don't have to hold that. I can take this probe and I can go all over as far as it'll reach with the wires and take my measurements. Okay, I go to the ground side, and there's actually a tiny little bit of a loose connection somewhere along there, but that's not enough to worry about. But you see the point, okay? And there we've got 12.45, 46, got 12.35, and if I turn the switch off, then you see I don't have it, because now this side is connected through the light to ground, and since there's no current flowing, we're not doing any work in the light, and there's no difference in voltage between this point and my ground or my negative battery terminal. If I go back to the other side of the switch, then you see the voltage, and we know that it's there. And the same thing, okay, if I connect there, even when the switch on, and I connect there, I get 0. That doesn't mean there's 0 volts. That means there's no difference between those 2 points. There's no voltage difference. There's no voltage difference between, well, there's a little bit because I have a bad connection or dirty switch contacts or something. And then if I turn the switch off, now we see the full 12 volts. We're dropping the full 12 volts across the switch. And that's how you take voltage measurements. Something else I want to show you. Sometimes when you're testing things out there, especially in the engine compartment under your hood, you might need a voltage reading on a wire, but you don't have a good place to touch that wire with your meter lead. And one thing you can do, and you'll hear about this and read about it in the forums or in books, is called back probing. And let's just pretend that this right here is a plug, and all the wires are going into that plug, and you can't see any exposed places to connect your meter. So what you can do is take a little pin, like your wife or mother used for sewing, and take that and pierce the insulation, poke it right in there. And it's not always easy. You might need a pair of pliers like this so that you can get that poked in there good. All right. And when you do that, then what you could do is take a little test lead like this and connect it to your meter lead. Okay. And you could have your other side connected to ground, and then take your voltage measurement. Now you see right now we don't have voltage there because the switch is off. I turn the switch on, and there we go. That's how you back probe, or use a pin or a sewing needle to gain access to a voltage point in a wire. When you're finished with that and you pull the pin out, you should seal that up. Maybe a little bit of some caulking or something, liquid electrical tape or something like that, so that moisture doesn't get in that hole and cause the wires to corrode and become a bad connection later. Your test light can also be used to get your check engine light codes in an OBD1 system. That's the older vehicles before, I think, 95 or 96. Under your hood, near the fuse box, you should have a connector like this. Ignore the red wire temporarily. And mine was clipped up under this little plastic cover that says EEC test. And then there's also a little single wire here. And the procedure for this is on our website on therangerstation.com. You can look it up, OBD1 testing, and you'll find this procedure. But you need a jumper to go from this single wire. This is like a test input, or this is a self-test port, and then this is an input for that. So you connect those two with a jumper like this, and then you could take your test light, and you don't see the other end, but I have the other end hooked up to battery positive, and you take and you turn the key on, engine not running, and key on. And this, you see there's 1, 2, 3, 4, 5, there's actually 6 ports in this plug. One of them does not have a connector in it, but on the long row, the second one from the left like this is where you connect your probe. Okay, I cycled the key off and back on again to reset the test, and there you go. So first code is a 2, a 3, oh, I'm sorry, there's a 1, that means, okay, the first digit is a 2, and the second digit is a 2. So I believe our code is a 22, and I'll look that up here when I edit this. But what that should be telling me is that we have a problem. Oh, okay. I'm sorry. It's giving another code, and it repeats each code. So that's a 5 and a 4 and a 2. So we had a 22 and we had a 542. And like I said, I'll look that up and make sure I get that in the video to tell you what the code is. But I unplugged the throttle position sensor to do this so that I would have a fault code. And we can also do that with an analog meter. Meter like this, you hook the meter up the same way. I have one probe going to the positive battery lead, and I hope you can see that. And then the other one will go back down in here. I just reset it, and now you can see what it does. You don't really get much of a voltage reading, but it makes the needle move and you get those blinks. There was a single. There's a 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2. And that's how you get that code. A digital meter does not work very well for this because it does not respond fast enough. You may see the display blinking some numbers, but it really doesn't work well for this test. So use your test light or an analog meter like I just did, and you can get your codes just like that. And like I said, the procedure is in www.therangerstation.com in the technical articles. Next, let's talk about measuring resistance. We'll use the Ohms scales on our meters, and we can tell whether something has a direct short, which would be 0 ohms of resistance or no resistance, or if it has some resistance, like a light bulb or the coil on a maybe an air conditioning compressor clutch or something like that, or if something is burned open and it has infinite resistance. So let's start. We're going to use the little analog meter here first, and you need to pick a scale, and I'm not sure how many ohms. I'm going to read the resistance on this light bulb first, and I don't know, so I'll pick the middle scale here up to 100 ohms. I'm very sure it'll be less than that. But first you want to calibrate your meter, and just take it and make sure your leads are plugged in and touch them together and squeeze them together good, and that should go to 0. If it doesn't quite go to 0, there's usually a little adjusting screw here, and hopefully you can see this. If I turn that, well, this one's really not doing much, so oh, there it goes, I think. Okay, I had a loose meter lead. So there, and you adjust that until it reads 0. Now you take your leads and you put them in parallel and make sure your circuit is de-energized. You never want to measure ohms or resistance with an energized circuit. So I'm going to, I took my ground off the battery over there, so we're de-energized now. And then you touch your probes to both sides of what you're measuring, and that came out to be very, very little. Let's try the 10 ohm scale. And that's not perfectly zeroed, but I'm going to try that. Okay. And we're getting about 3 ohms roughly. You're not going to get perfectly accurate results with a meter like that, simply because it's just not made for being perfectly accurate. It's made for giving you something to give you a rough idea. Let's try the digital one here and see what we get with that. I already had it set to the lowest scale. All right, that's telling us we have 4.5 ohms, 4.5. And that's about what I'd expect. Now you're starting to see the quality of test equipment. I could also use my real fancy meter here, and we'll check that one. And you see it. We go, it'll take a second and it would steady out down to 0. My meter leads might be a little dirty, but that's close. And there we get 4.2. So you see my cheap digital meter is pretty darn close to my really good digital meter. Here, I can do this, and it's still not zeroing out. I don't have an adjustment on this meter, and the batteries might be getting a little old. But really, that's close enough for what we would need. What we would want to test, and I'll go back to using one that's probably more like a lot of you have, and we could test the light bulb like that. We could test a fuse, okay, and you remember we have the little things here on the top of the fuse, so if it's still in your truck, as long as you've got the battery disconnected and everything's disabled, you can see. And a fuse should be a direct short. That should be 0 ohms, but that's close enough. I could try going across my terminals. And you see, like we found out earlier, reading voltages, I have some dirty connections somewhere in here. And you could check a switch. You could see if a switch, and this is just a toggle switch that you would operate by hand, but let's say maybe it's a low pressure cutout switch for your air conditioning system. It's the same thing. It's just a pair of contacts that open or close to give you continuity. So you see right now the switch is open, and this is how this meter tells you that you do not have, or that you have infinite ohms, that you have an open circuit. And it goes to 0 when you shut it. So, okay, the switch is open. Now I'll reach with my pinky and close the switch, and there you can see the switch is closed. You turn the switch on and off, you see a change of state. And you know the switch is working. Again, this is not a greatest quality meter, but you see that it does work good enough for doing this. And that's how you do it. I've got some other devices I could show you. Well, we could, up here we have a relay, and we could measure the resistance of the coil in the relay. And that would be the black and white wires here. And there we have about 68.2 or 68.1 ohms. That's the resistance across the coil in that relay. My normally open contacts, you see, are open. I do not have continuity. If I reach over there, I don't have that wired in the circuit right now, so I can't turn it on electrically. But if I do this, I push the contacts shut, and you see there's some dust and dirt in there. But it's going down. Let's see if that helped. There we go. And we see the contact close and open. And that's how you check ohms. You can check that across wires. And say you've got a wire going from one end of your engine compartment to the other. You don't know if that wire is broken or not. So just find a terminal on one end of it and terminal on the other, and you can measure the ohms. You can see that that wire is good. And that's all there is to it. That's really simple, and you'll see us recommending that a lot when you write in on the forum and you're asking questions about how to troubleshoot something. That's a very important tool to do. And sometimes you may have something that would have a higher resistance to it. So there are higher scales. This meter will go up to 200 or, well, yeah, 2,000 or 2 million ohms. I'm having trouble believing this meter would read that accurately, but it says it will. Okay, the last thing I want to show you with your meter is how to measure current, or the number of amps flowing in a circuit. And this is a little bit different because to do this, the meter has to be in series with the circuit. It has to be connected in just like a piece of wire between 2 points. So in my little sample circuit, you see I disconnected this wire, and then I have my red meter lead connected to this terminal up here. And so the current will come through that lead, through the meter. And on some meters, you have to plug your lead into, one of your leads into a different port to read amps. And you can see that here. There's a note that says 5 amps DC, go to that port. So I plugged my red lead in there. My black lead stays in the common. It comes down, and I've used a test lead and I have it connected here. So then our current continues on over to the negative side of the battery. So in order to do this, like I said, your meter has to be connected in parallel or in series in the circuit so that it senses all the current in the circuit. And there's a limit. Okay, you can see this one will do up to 5 amps. It's usually a fairly low current. Some better meters will do more than that. And my good meter here, it has several scales. It'll do milliamps and amps. Let's see, it'll do up to 10 amps maximum. So that still isn't very much. So once you have your meter hooked up, then apply the voltage, make sure your battery's connected again, and then turn your circuit on. And now you'll see our light's on, so we have a complete circuit, and we're reading the current. It's 0.32 amps. So that's not very much. And that's well within the capabilities of our meter. So our circuit starts from the battery and positive. We go through the fuse, through our switch, and over through the light. And coming out of the light, I'm going to the meter through the red lead and back out of the meter through the black lead and back to our negative terminal. I could have hooked this up on the positive side of the circuit and it would do the same thing. It's a little bit safer if you can do it on the negative side of your circuit. And I'm going to do another lesson later on for troubleshooting parasitic draws on your battery. If you got something that is making your battery run down real fast, that's usually called a parasitic draw. And it means that there's something failed in your truck, there's something shorted, or something is not turning off like it should when you take the key out of the ignition. And you have to troubleshoot that so that you don't keep running your battery down all the time. So this is how you'll do it. We will, when we get to that lesson, I'll hook a meter up in series in the circuit with the battery, and then we'll check for parasitic draws. And that's it. So those are the 3 most common uses for your test equipment, for your meter or your test lead. And you'll see the test lead, like I said, it's very limited in what it'll do, but it's very useful, especially out on the trail. If you just need to see if you're getting voltage to something and where the voltage is being lost, that test light, like I showed you at the beginning of this lesson, can bail you out a lot of times. I prefer to have a meter with me, but not everybody can afford to have a meter every day. If you can get a cheap one like this one, or my little cheap analog one, 10, 20, or 30 bucks, You know, that really isn't that much, and it'll help you in a lot of cases. The last thing, when you're finished with your meter, always turn it off. And you see this one has a on-off switch right there, so you can leave the knob in any scale you want. On this one, there's no on-off, so normally you just turn it to one of the AC voltage scales because it will not be using its internal battery on AC voltage measuring. So that's how you turn that meter off. Thank you very much. That brings this lesson to a close. If you think this video was helpful, please click the like button or maybe even subscribe to my channel. Come back soon for more episodes. I also invite you to join me and my friends at therangerstation.com. It's a website featuring Ford Rangers and other Ranger-based vehicles, where you will find Ranger news, articles about members' vehicles, an active forums section, and an excellent tech library. Come join the fun. Thank you for watching Libby's Ranger Garage.